Question 6. An aircraft is 144 kilometers east of the airport and is traveling west at 200 kilometers per hour. That's the speed. At the same time, a second aircraft at the same altitude is 60 kilometers north of the airport and is traveling north at 150 kilometers per hour. How fast is the distance between the two aircrafts changing? You can't do anything. Maybe should be able to easy. What is the problem? Yes. So if you can see the screen, then you have to be able to get me now. So how is the structure like? So suppose this is the airport here. Then we have this structure here. So we'll say, okay. So what's happening is that we have this plane 1 here. So we put the plane here. And then plane 2 the other side. This is plane 2. Then you want to calculate. No, in application, things don't get visualized directly. So understand that since this is going this side, and this is going this side, so what is increasing is this space. This is space in between here. So in terms of distance, what we calculate is actually this one here. That's what we will calculate, because that's around that times the space that is increasing. So suppose we call the increase in the distance of plane 1 to be x, the increase in the distance of plane 2 to be y. Then we know that now this is sitting on, this is a 90 degrees angle here. So it means that the other side by Pythagoras theorem takes the shape of x squared plus y squared. If we use the Pythagoras theorem. And then, well, we're given something here. It's not too plain that we don't know anything about x. We know something about x. We know something about y. What do we know? We know the rate at which, from the question, we have an aircraft is 144 kilometers east of the airport and is traveling west at 200 kilometers per hour. So it means that, let's see, then the other one, we have at the same altitude is 60 kilometers north of the airport and is traveling north at 150. Okay, so this one that is traveling north, this is a change in y. So we have a change in y with respect to time, of course. So this, it's north and it's traveling north. So we get the whole 150 here as a change. Of course, with its units. And then this one is not going inside. So let's mix it. Okay. So this one that is east is not traveling east, it's traveling west. So we have an opposite direction there. So it means that its change of distance, which is 200, is going to be negated. So it's like it's covering up. So the arrow is something like this. Then this is up. like that. So something of this nature to visualize. So I want to calculate this distance here. And we have that information. So because you're given the distance, so you're saying, oh, the distance then that you're talking about is going to be this guy, which I like writing as this in derivatives because it's easy to differentiate like that. Also, every time, maybe I give you something that is very, very simple to understand. We'll get back to this page. Let's talk of questions like, let's talk of question 7. If I have two positive numbers, x and y, and I'm told the sum x plus y is equal to 7, and you're looking for the largest possible value of their product. So what is the largest possible value of their product? Meaning you must find the values x and y, or even if you don't find them, you have an idea of the largest possible value of their product. So meaning this function is fixed, that is the sum. Then you get the product function. You know the product is just to multiply the two. Now, we have two functions here. One is a purely known function that if you add the two numbers, you get 7. The other one is hanging in air. You're just looking for the largest possible product. So this one depends on the other function. So what you do is the complete equation, you say, okay, if I let y to be 7 minus x, then I'll come back here and make it be a function of x. And then where there is y, I'll take a 7 minus x, and this becomes 7x minus x squared, which you can write as negative x squared plus 7x. It has become a quadratic. If we take it as first years, then we'll get the line of symmetry, which is given by negative b over 2a. And this is just negative 7 over 2 by negative 1, which is going to give us 7 over 2. This is the value of x. Then you go to y and say, wow, because now I know what x is, I have brought this value here. And then you get, this is 2 here, 14 minus 7, giving us another 7 over 2. So x and y are equal. Well, we have no doubt that this is going to give us the largest, because remember in the quadratics, this is ax squared plus bx plus c is equal to 0. And we say if a is less than 0, then we obtain maximum. If a is greater than 0, then we obtain minimum. So if we took it as first, then we'd say, oh, so the largest possible product is now equal to x is 7 over 2, y is 7 over 2, giving us 49 over 4. This is the largest possible product. Don't we need any units? In this course, the idea is not necessarily to be looking for the line of symmetry. The idea is, because I've got so many theories, we say, okay, if I get the function, of course you reach here, you get the function negative x squared plus 7x. After you've combined the two functions, then you differentiate. You get dp over dx, which is going to be negative 2 2x plus 7. That's a derivative. And then equate the derivative, equate the first derivative to 0. So now this implies that we have negative 2x plus 7 is equal to 0, giving us negative 2x is equal to negative 7. Divide by neg2, divide by neg2. So x is equal to 7 over 2. The very x that we found here, 7 over 2. Then because you would have had this equation also, for you to be able to substitute in here to come up with this one, then you substitute to get y to be also 7 over 2. Then now you want to decide whether it will give you the maximum or the minimum. You go to the derivative, you said this is dp dx is equal to negative 2x plus 7. You differentiate it again to get the second derivative. And what we find here is negative 2, which is less than 0. If the second derivative is less than 0, then you know that what you're obtaining is maximum. Or if the second derivative is positive, then you're obtaining minimum. So this gives us a guarantee that when we multiply the two, 7 over 2 and another 7 over 2 to get 49 over 4, then you are sure that this is the largest possible product. So this is the idea of this course. This is how this course is going to be applying the derivatives. So this was easy to follow, I assume, so that when you get back to this one, you have the function d, and it's a function that we can not try. This is just a one thing. Here we had 2, so it was easy for us to solve for this variable, substitute and deal with only a single variable. But in this case, we have 2 variables to deal with. But we still go on and differentiate. Okay, because these variables that we have, remember, they are sitting in here. They are sitting in here as this is a function of t. And this x as it is sitting here, it is sitting like x of t squared plus y of t squared, giving us, to the power half. But the t's are silent inside there. But they're the ones that are impacting. No, look, for even as they are given here, 150 kilometers per hour. The distance won't just move, it will move per given time. So that to differentiate this, you say, now I want to differentiate this distance that I'm given with respect to t. So you first get the half, you ignore the t, we're fixing them inside, and then negative half. But we know that x is a function of t, y is a function of t, and we are differentiating d with respect to t. What you have done here is just to differentiate it with respect to the variables x and y. So now we'll go inside and differentiate the x's. So you say, oh, I will differentiate 2x. The x squared becomes 2x. But in it, it has the variable t. So you respect that. Plus 2y, in it, it has the variable t. So you respect that. This is a product. So that dt, derivative of, also it's like dd. So derivative of this distance with respect to t is going to be half. And then, do we need to put it together? Or we just work out the single variables, because these we we've already listed them here. We have 150 km per hour. Then we have 200 and negative 200 km per hour. That is the x dt and the y dt. What about x and y? Let's get back to the question. An aircraft is 144 km east. So it means that the actual x is 144. And 60 north. So it means that this y is 60. So we get back here now and say, okay, so x is 144. So 144 squared plus y 60 squared negative half. And then 2x 144. And dx dt is negative 200 plus 2y is 60 and dy dt is 150. So to make a difference here, I'll use these brackets like this. Then, so we have something like 1/2, and then the square root because that half is negative there. Then we add now 144 squared. Let's start the calculations. I'm ready for my calc. Okay, so 144 squared plus 60 squared, we get 24336. This multiplied by the numerator there, that is 2 by 144 by negative 200. Okay, let me just do 2 by 144 and then by 200. Because I know it's a negative, so I'll put negative 57600 plus 2 by 60 by 150. That is 18,000. Okay. Then we add those, so minus 57,600. That's giving us neg 39600 over 2 multiplied by the square root of 24336 plus that is 3 4. And then now divide neg 39600 divided by 312. That's saying negative 126.923 kilometers per hour. So that's the rate at which, and it makes sense because the the distance is getting squeezed, like it's reducing, because you look at the speed at which this one is moving. You look at the speed of this one here that is getting to the North Pole. So this is the airport and this is the North Pole. Then we are saying this one is heading to the North Pole as this one maintains the North Pole and goes up. So what is happening is that this one is going up at a slower rate as compared to the rate at which plane one is getting to the North Pole, which is sitting on the airport now. This is 200 kilometers per hour. That is higher than 150 kilometers per hour. So even if they ask you to say, okay, if they were to head the same direction from where they are there, at what rate do you think plane one will catch plane two if they maintain the speed 150 kilometers per hour and then the other one 200 kilometers per hour? You should be able to tell, because engineers are the ones that are used in army to do such calculations. So if that's a jet in Ukraine moving at that speed, you should be able to calculate. Okay, so I've done two questions at the same time, question 6 and question 7. Question 7, we used it to illustrate on how you apply the derivatives where you're dealing with two functions, and like getting the solutions via the first way method. Okay, we can now go to question 8. If there are no questions pertaining this one.
Sir, sorry, I'm a bit lost where we got 144 and 60.
144 at 60. So we are given, if I can just squeeze this one here. So I've said this is plane 1 and this is plane 2. At the moment the study is being carried out, we are told that this distance where this plane is from the airport, the distance is 144, which we have called x, the distance from the airport to plane 1. The distance from the airport to plane 2, which we have called y, is 60. And then because these planes are not stationary, they are moving. So as they move, this one is moving in this direction. At what speed? At a speed of 200 kilometers per hour. The other one is moving at the speed of 150 kilometers per hour. But look, the one that is moving 150 kilometers per hour, it's on the north part of the airport and it's heading north. So it's going in this direction, north. The other one is east and it's going west. So it means that if it was going east, then we would have said, well, it's maintaining because it's going away from the airport. Now it's heading to the airport. So we put a negative. Why putting negative? We want to calculate the space, I mean the rate at which the distance between the North Pole and the distance between the two planes, plane 2, which is heading north, and plane 1, which is heading west, though it's east.
I get the point now, sir. Thank you.
Okay. I think in 8 minutes we can finish question 8. Two negative numbers have some Two negative numbers have sum 60. What are the numbers if the product of one of them, if the product of one of them and the square of the other is maximal? So here, if we go to this one, and so for let's now solve for x, we'll get 60 minus y. Then we come here and say 60 minus y, y squared. So what we are saying is we're making the function be a function of y. So when I put a py there, I just mean I'm now free throughout the function. I'm just dealing with one variable, which is negative y3 plus 60 y squared. So we differentiate this one with respect to y. We'll get negative 3 y squared plus 120 y. And then we equate this to 0 from the concept that we used to solve question 7. So we'll have negative 3y squared plus 120y is equal to 0. Divide by negative 3, divide by negative 3, divide by negative 3. We are getting y squared minus 40y is equal to 0. So if we factor out y, we'll have y minus 40 is equal to 0, where y is 0 and y is 40. So we have two values of y there. Then we go here and say, okay. Then we go to x, say x is equal to 60 minus 0, which is 60, or x is equal to 60 minus 40, which is 20. What is so awkward here is that the numbers we are finding are positives, and then the question demands for negatives. So like my hope was out of these two, one is going to produce some negative, but they're all positives.
How about if we change just the sign there, sir, where x plus y equals 16, it come negative at some point.
If now let's say negative x minus y is equal to, but it can't make sense. So unless we say x minus y is equal to 60, still because this is like a negative. Okay, maybe like if this is negative 20 minus negative 80, you can get a 60. Yeah, but in reality, I've tried this thing, but it's not making sense. Two negative numbers have sum 60. except it can't just be possible. You can't add two negative numbers, you put a plus and they're all negative, and you get a positive sum. What numbers are those? Like if we, I don't know, it's not making sense. Like you add two numbers that are negative and you get a positive value. I don't know. So if they were positives, then they could have been found as options of 20 or 60. And then you look for the maximum product. So of course, if you use 20 by 40, what you get will be less than 60 by 40. I accept again the pairing 60 by 0 or 20 by 40. So 20 by 40 was going to win because it gives us a maximum value of the two products. Because even if we had to say, okay, we're now looking for the product, the other one is 60 and then 0 squared. This will give us 0. The other one is 40. Why? No, we start with 20x and then 40 squared. So this will be bigger than 0. So it opt for x is equal to 20 and y is equal to 40. But they can be negative. I hope we all agree. Don't know what Dr. Banda meant here. No. I don't think he read this question. Well, how can two negative numbers have the sum 60? Maybe it was negative 60. Yeah, would work. Can't have a positive sum when the numbers are negative. That's not true. Okay, so yeah, I was just showing you that. Yeah, I was just showing you that I'm ready to teach. So we'll continue tomorrow if you are ready to learn.
So tomorrow, what time?
At 19.
All right, thank you.